Okay, think about that silent guardian in your house, working away, whether it's freezing Canadian winter outside or boiling hot summer.
Right.
It's not that flashy smart thermostat. It's much simpler, but really, really crucial. Your HVAC furnace filter.
It is pretty amazing, isn't it, how this, like, inexpensive little thing you swap out plays such a huge role, but most people barely give it a second thought.
Exactly. And that's what we're really getting into today. We're doing a deep dive based on the ultimate guide to HVAC furnace filters. It's by Eldad Rubin, owner of Heat Lab Enterprises, Inc., up in Alberta.
Yeah, I read through it. It's surprisingly comprehensive,
Aaron.
really educates you on something you just assume is simple.
So, our mission today for you listening in is to figure out why these filters are so vital. For a healthy home, clean air, even getting rid of smells, it's way beyond just catching, dust bunnies.
Definitely.
Think of this as your shortcut to getting properly informed on this seemingly straightforward topic.
And Eldad Rubin's guide makes it clear the benefits go in, well, several directions. You're protecting your HVAC system itself, which isn't cheap.
Right.
They're making it run more efficiently. And, maybe most importantly, you're impacting your health by grabbing all sorts of nasty stuff out of the air.
Precisely. So we'll break down the different filter types, try to decode those MERV, NPR, FPR ratings. They look like alphabet soup sometimes.
You really do?
We'll bust some common myths that might be costing you money or affecting your air quality, and really hammer home why changing them regularly is just essential. By the end, you should feel pretty confident choosing the right one. Okay, let's get started.
So one of the first things that jumps out from the article is just how critical good filtration is, especially, in places like Canada or the northern U.S. where winters are serious.
Right. Eldad Rubin points this out when we seal our homes up tight for winter, which we have to do, right? Keep the heat in. We also trap everything else inside. Dust, allergens, pet dander, cooking fumes. It just recirculates.
Yeah, it creates this kind of closed loop. So the article really frames the filter not just as a part, but as like a key player for a healthy home or even a productive office space. It's not minor.
It's a cornerstone, almost.
Yeah.
And it's got that double benefit, doesn't it? It's about breathing easier, sure, but also making sure that big, expensive furnace or AC keeps running properly.
Exactly. Let's talk about protecting the system first.
Okay.
It's really important to realize as air gets pulled into your system for heating or cooling, it goes through that filter first before it hits things like the blower fan or the heating and cooling coils.
Okay, so what happens if the filter is, like, dirty or just not up to the job?
Well, think about dust building up on the fan blades. The article mentions this can actually unbalance the fan.
Oh, really?
Yeah, which means more noise, maybe less air getting pushed through, so it's not heating or cooling as well, and it can cause extra wear on the motor over time.
A noisy, weak furnace. Not good.
Not good at all. And then there are coils. If dust coats them, it acts like insulation. So it can't transfer heat properly. Your furnace works harder, runs longer. Same idea with cooling coils. It messes with dehumidification. And worse, that dust and moisture combo can become a breeding ground for mold inside the system.
Ugh, mold blowing through the vents. That's
Yeah.
not a pleasant thought.
Definitely not.
Right.
And in like extreme cases, if a filter is totally plugged, the lack of airflow can actually cause the furnace's heat exchanger to overheat. That can trigger safety shutdowns, lead to expensive repairs, maybe even needing a whole new furnace.
Wow, so spending a few bucks on a filter regularly could literally save you thousands down the line.
Yeah.
That's pretty clear.
Yeah, the math works out.
Okay, let's switch gears to what most people probably think of first. Breathing cleaner air.
Right. And this raises a kind of startling point the article makes. Have you ever thought that the air inside your house might be way worse than the air outside?
It feels backwards, yeah. You think you're escaping pollution by going indoors.
Exactly.
Yeah.
But our homes are so well sealed now for energy efficiency, which is good in one way, but it traps pollutants in. Think about cooking, cleaning sprays, just walking around stirs up dust. Pets mean dander. Damp basements mean mold spores. And then there are VOCs, volatile organic compounds, from furniture, paints, all sorts of stuff.
Okay, VOCs. Let's put a pin in that for a sec. How does the filter actually help with all this indoor gunk?
Well, a decent filter basically acts like your home's air purifier, running whenever the HVAC system is on. It's constantly pulling air through, trapping those particles.
So it's an ongoing cleaning process.
It is. And how well it works depends on the size of the particles it can catch. The cheap basic ones might only get big lint.
Right.
But better filters are designed to grab smaller and smaller stuff. Pollen, mold spores, pet dander, even down to microscopic things like bacteria, maybe some viruses.
From visible fluff to invisible irritants, that's quite the job.
Now, Eldad Rubin also mentioned filters that tackle odors and those VOCs. How on earth do they do that?
Okay, this is where you get filters with activated carbon. The cool thing here is a process called adsorption. AD.
Adsorb. Yeah, think of it like molecules sticking to a surface, not soaking in like a sponge.
Okay.
Activated carbon has this incredibly huge internal surface area, like tons of tiny pores.
Okay.
And these pores trap gas molecules, the stuff that causes odors from pets, cooking, smoke, and also those VOCs we talked about.
So it's like a microscopic sticky trap for smells and chemicals.
That's a pretty good way to picture it, yeah. And it's super useful in those tightly sealed homes because those gases have nowhere else to go.
Makes total sense. Now, something else mentioned was energy efficiency. How does a filter affect my power bill? That might surprise some people.
Yeah, it's a direct link. A clean filter lets air move easily.
Right.
So the blower motor doesn't have to struggle. Less struggle means less electricity used. Simple as that.
Yeah.
Lower heating and cooling costs.
So cleaner air, protected system, and saves a bit of money. That's a triple win.
It really is. Now, flip that. Think about a dirty, clogged filter. It's like trying to breathe through a thick cloth, right?
Yeah.
The motor has to work much harder, uses more power. The whole system runs less efficiently, meaning it has to run longer to get your house to the temperature you want. And those longer run times definitely show up on your bill.
Okay, so regular changes, good for air, good for the budget. Now, the article really stresses why this gets even more important in winter, especially in places like Alberta. Why is winter worse?
Well, several things pile up in winter. We already talked about sealing the house, trapping pollutants, but also we just spend way more time inside, right?
Sure.
The heating system itself can kick up dust that's settled, and the air tends to be drier, which can make our noses and throats more sensitive to irritants anyway.
It's like a perfect storm for bad indoor air.
Kind of, yeah. So a good filter in winter can really help. It can cut down on circulating germs, maybe reducing how often colds spread. It minimizes those allergens that get concentrated indoors.
Right.
And of course, it tackles those stale, trapped odors.
Health, comfort, maybe fewer sick days. Got it.
Okay, let's try and crack the code on these ratings. MRV, MPR, FPR. Feels like you need a science degree sometime.
It can seem that way. Let's start with MERV. That's the main one. Minimum Efficiency Reporting Value. It's the industry standard from ASHRA.
Okay.
It's a scale, 1 to 20. Higher number means it catches smaller particles, specifically in the 0.3 to 10 micron range.
So what do those numbers mean practically? Like what's a MERV 8 good for versus a MERV 13?
Okay, so MERV 1 to 4, that's your basic, often cheap fiberglass filter. Catches big stuff like lint. Mostly just protects the furnace itself, not really for air quality.
Got it.
MERV 5 to 8 is better. Starts trapping things like mold spores, pet dander. You'll notice an improvement.
Yeah.
MERV 9 to 12, now you're in high-efficiency residential territory. Much better at grabbing finer allergens like pollen. Good for allergy sufferers.
Right.
MERV 13 to 16 is very high efficiency. Can get smoke particles, some bacteria. MERV 13 is often kind of the max recommended for a typical home system, though.
Why is that? Can I just grab the highest one?
Uh-huh.
That's a critical point. Higher MERV means the filter is denser, harder for air to pass through.
Resistance.
Exactly, airflow resistance. If it's too high for your system, the fan strains, efficiency drops, you could even damage the unit. So MERV 1720, that's HEPA level. Amazing filtration, but needs a system designed for it, or a standalone purifier.
Okay, so check compatibility. The article mentions consulting pros like HeatLab if you're unsure.
Definitely a good idea. Don't guess.
What about NPR and FPR then? Are they totally different?
They're different scales, but related. NPR is 3M's rating for filtrete filters. It focuses on really small particles, 0.3 to 1 micron, so the numbers look higher. Like an NPR 1000 might be roughly like a MERV 11.
Okay.
And FPR is Home Depot system. Simpler scale, 4 to 10, often color-coded. And FPR 7 is also around that Ember 11 ballpark.
So they're just different ways of measuring similar things?
Pretty much. The point is, understanding them helps you compare and choose based on what you need, maybe better allergy control, maybe basic protection, and what your system can handle.
Okay, that clears things up a bit. Now, the actual filters themselves, fiberglass, pleated, electrostatic, what's the difference when I'm looking at the shelf?
Okay, fiberglass first. Cheapest option usually. And MERV 1 to 4. Like we said, protects the system from big stuff, doesn't do much for air quality, lets airflow easily, but you got to change them often, like every month.
Okay, cheap but basic. Next.
Pleated filters.
Yeah.
Super common. MERV range is wider, maybe 5 up to 13. They're made of, well, pleated material.
Folds, yeah.
Right, folds. Gives way more surface area to trap stuff like pollen, dander. They usually last longer, maybe 60, 90 days. Good balance of performance and cost for most people. But again, higher MERV means more airflow restriction.
Pleated sounds like a solid middle ground. What about electrostatic? Sounds fancy.
They use static electricity, like a magnet for dust, usually MERV 8 to 12 range. You can get disposable ones or washable ones.
Washable.
Yeah, can be good for pets, smokers, allergies. Disposables are probably more consistent, though. The washable ones, you have to clean them really well and let them dry completely, otherwise you risk mold. Some people notice a faint ozone smell, too.
Okay, trade-offs there. Then the top tier, HEPA.
HEPA, high-efficiency particulate air. MERV 1720 captures like 99.97% of tiny 0.3 micron particles. Amazing for bacteria, viruses, but huge airflow resistance. Not for your standard home furnace, usually. Needs mods or, like we said, standalone units.
Right, specialized stuff. And lastly, the activated carbon ones for smells.
Exactly. They usually have a particle filter layer too, maybe M8 to 13.
Right.
But the key is the carbon layer that absorbs the gases, odors, VOCs. Great if you have pets, smoke, or chemical sensitivities. The carbon does get used up, though, so might need changing more often if odors are strong. A bit pricier, but really valuable in those sealed homes.
So many choices. It really depends on your priorities and your system.
Absolutely. Budget, air quality goals, HVAC specs, got to balance them all.
Let's go back to that activated carbon for a minute. You said adsorption, not absorption. Can you unpack that a bit more?
Sure. Think absorption like a sponge soaking up water. The water goes into the sponge material.
Right.
Adsorption is different. The molecules, like odor molecules or VOCs, just stick to the surface of the material. Activated carbon is processed to have this massive internal surface area, like a maze of microscopic tunnels and pores.
So tons of surface for stuff to stick to.
Exactly. That's what makes it so good at trapping those gas molecules as the air flows past.
Okay, that makes sense. And what kind of smells and VOCs are we talking about? Is it just cooking smells?
Oh, it covers a lot. Pet odors, definitely. Cooking, smoke, musty smells, bathroom odors. And VOCs from paints, cleaning products, new carpets, furniture off gassing, you know, that new furniture smell?
Yeah.
That's VOCs. Carbon filters help trap those. It makes the air less irritating.
And those VOCs aren't just annoying smells, that they can affect health.
They can, yeah. Depending on the chemical and the level of exposure, they can cause anything from headaches and nausea to more serious long-term issues. So reducing them is definitely good for a healthier indoor space. Plus, for people with asthma or allergies, removing chemical irritants on top of particles can be a big help, especially in winter, again, when everything's trapped inside.
So combining carbon with a good particle filter, like a MERV 11 or 13, it sounds like the best all-around approach for many people.
Often, yes. It gives you that comprehensive filtration for both particles and gases.
Okay, great. So we've picked our filter. We understand the type, the rating. Now, the million-dollar question. How often do I really need to change it? People guess, right?
They do, and guessing isn't ideal. It's so important because even the best filter is useless once it's clogged solid. It just blocks airflow.
Right.
The frequency really depends. Basic fiberglass, every 30 days usually. Pleated, generally 60 to 90 days is a good guideline. Carbon filters, also maybe 30 to 90 days. Depends how much odor or VOCs it's dealing with. The carbon gets saturated. APO, if you have it, maybe 6 months to a year plus.
Yeah.
And washable electrostatic, you need to clean them monthly, and they still wear out after a few years.
So there are guidelines, but it's not set in stone. What makes the timing vary for my house?
Well, lots of things. Do you have pets shedding? Does anyone smoke inside?
Right.
Allergies or asthma in the family? How many people live there? Have you been doing renovations, kicking up dust? What's the air quality like outside where you live? And simply how much you run your heating or AC. All that affects how fast the filter gets dirty.
So I need to be observant. Are there clues, signs that tell me change the filter now, even if it hasn't hit 90 days yet?
Definitely. The easiest one is just look at it. Hold it up to the light. If it looks choked with gray gunk, change it. Other signs. Feeling less air coming out of vents, more dust settling on furniture than usual. If you have a carbon filter or smells coming back. Is your furnace or AC seeming to run longer to heat or cool the house? Maybe allergy symptoms flaring up for no reason. Those are all hints the filter might be done.
Good signals to watch for. Okay, say I'm doing this for the first time. Is it hard? How do I actually swap it out?
Nah, it's usually super easy.
Yeah.
First, safety. Turn your system off at the thermostat. completely off.
Got it.
Then find the filter slot. It's usually a slide-in compartment either right near the furnace air handler unit itself or in the main return air duct.
Okay.
Before you pull the old one out, look for an arrow printed on the side showing airflow direction. Make a note of that. Also, check the size printed on the filter frame.
Yeah.
You need the exact same size replacement.
Size is critical.
Absolutely critical. Okay, slide the old dirty one out, slide the new one in, making sure the airflow arrow points the same way the old one did, usually towards the furnace guts.
Arrow towards the machine.
Right. Close up the panel or door securely. Then go back to the thermostat and turn your system back on. Done.
Sounds totally manageable. The tricky part is just remembering to do it.
Yeah, set a calendar reminder. Phone alert, sticky note on the fridge, whatever works. Make it routine.
Good tip. Okay, let's zoom out again. The guide also talks about the bigger impact health, environment, beyond just my house.
Right, and this really underscores the why. We spend, like 90% of our time indoors?
Probably.
And the EPA consistently finds indoor air can be more polluted than outdoor air, sometimes significantly more. And that poor air quality links to all sorts of health stuff. Headaches, fatigue, irritated eyes, nose, throat, worsening asthma, allergies, even longer-term respiratory issues.
So better filters, like maybe a MERV 13, can actually make a noticeable difference in health outcomes.
The evidence suggests yes, reducing allergens, potentially lowering infection transmission by catching more airborne germs, improving sleep, helping kids, the elderly, is a real factor in well-being.
That's powerful. What about the planet? All these disposable filters going in the trash?
That's a fair point. Landfill waste is a downside. Some filters have cardboard frames you can recycle, or maybe specific components. You'd have to check locally. Washable filters seem greener up front. But like we said, often lower MRV, need careful cleaning, still need replacing eventually, so it's not a perfect solution either.
Is there an environmental upside?
Yes, the energy efficiency angle. Clean filters mean your HVAC runs optimally, uses less energy, that lowers your carbon footprint. But again, got to have the right MRV. Too high, you waste energy. But if everyone used the right, clean filter, that collective energy saving actually adds up and helps the climate.
So small actions, big collective potential. Okay, let's bust some myths. Eldad Rubin's guide calls out a few common ones. What's the biggest one you hear?
Oh, definitely. The higher MRV is always better one. We've hit this, but it bears repeating. It's about compatibility. Too high restricts airflow, strains the system, wastes energy, could cause damage. Find the right high MRV for your system.
Got it. What else do people get wrong?
Thinking you only change it once a year? Or, I'll change it when I remember.
Guilty as charged, maybe.
Huh. Yeah, well, filters fill up way faster than a year for most homes. Clogged filter doesn't filter, it just blocks air. Check it regularly, change it based on its condition and the recommended schedule.
Makes sense. Do people think any filter gets rid of smells?
Yeah, that's another one. Nope. Standard filters catch particles, dust, pollen. Only ones with activated carbon actually absorb odors and gases. Need carbon for smells.
And washable filters, are they always the eco-hero?
Not quite the clear win people think. Often lower MRV, need that careful cleaning risk mold. If not dried properly, don't last forever. Can be okay, but not automatically better than a good disposable one changed responsibly.
Okay. Last myth. Upgrading my filter is too expensive.
Yeah, people see a $20 filter versus a $5 one in bulk. But the guide makes a good point. Look at the long game. Better health means maybe fewer doctor visits or missed work days. Energy savings add up. Preventing a $5,000 furnace repair?
Yeah.
Suddenly that $20 filter looks pretty cheap.
Total cost perspective.
Yeah.
Okay, myth busting complete. So final advice. I'm standing in the aisle, filter options everywhere. What's the checklist for choosing?
Okay, number one, non-negotiable. Get the exact CT size. Measure your old one or check the slot. It has to fit snugly.
Size first.
Then, MERV rating. Choose the highest your system can handle without choking airflow. For most homes, MERV 8 to 13 is that sweet spot. Maybe check your furnace manual or ask a pro if unsure.
Okay, compatible MERV.
Third, do you have smells, TETs, VOC concerns? If yes, prioritize one with activated carbon. It's worth it.
Harvey for odors.
Fourth, maybe consider brand reputation. Some cheaper ones might not perform as consistently as known brands.
Quality counts.
Yeah. The guide mentions a few examples that combine good particle filtering with carbon, like certain Filtrate, Nordic Pure, Honeywell models. Point is, options exist. The best filter. Fits right, MERV is compatible, tackles your specific needs like odors, and crucially, you actually change it on time.
Find that personal sweet spot.
Exactly.
Well, this has been incredibly informative. Eldad Rubin's guide and your explanations really shed light on something we don't think about enough. So if you had to boil it down, what's the single biggest takeaway?
That your furnace filter is doing way more than you think. It's protecting your expensive equipment, yeah, but it's fundamentally about the air quality inside your home. It's a health device, really. A small cost for potentially big benefits in health and comfort.
And especially critical where we live, spending so much time indoors during those long winters.
Absolutely. Winter makes it even more important.
So what's the one thing you hope listeners do after hearing this?
Just go check your filter. See what size it is. See how dirty it is. Figure out what type might be best for you next time. Start a schedule for changing it. Just take that first step. Cleaner air is achievable.
Okay, here's a final thought for everyone listening. Think about the air in your home right now. Is that filter working hard for you or hardly working? What one small change, based on what we talked about, could you make for a healthier home starting today? Eldad Rubin's guide emphasizes you don't necessarily need the most expensive option, just the right one, changed regularly.
And if you want more details or need specific advice for your system, Heat Lab Enterprises has more info on their website. It's heatlabent.company.site.
Perfect. Well, thank you so much for walking us through all of this really valuable stuff.
My pleasure. It's an important topic. Glad we could cover it.
We really appreciate you tuning in for this deep dive. We hope you found it useful. We'll catch you on the next one.